In this video, I'm going to be going over how we can perform operations on functions. So the first thing to discuss is what the notation means. So for example, this says f plus g of x. And so we have our f function, we have our g function. And what this is saying is for each of those, we're going to use x as the input. So for f plus g of x, what that means is f of x plus g of x. So this one's pretty straightforward. We just take the f function, x squared minus 6x plus 8. Then we're going to add that to the g function, x minus 2. And then combining like terms, we end up with x squared minus 5x plus 6. For the second one, f minus g of 4, now we have a real number as the input. And so what we're going to do here is we're going to say, well, f minus g of 4 means f of 4 minus g of 4. So then we just input 4 into each of these functions and subtract them. So f of 4, I'm going to do that over to the side here. So f of 4 is equal to 4 squared minus 6 times 4 plus 8. We get 16 minus 24 plus 8. Well, that's nice. That comes out to 0. So this is 0 minus g of 4. That's 4 minus 2, which is 2. So we get 0 minus 2, so this comes out to negative 2. All right, I'm going to erase this. The next one is f g of x. F g of x means, again, x is now the input. And so what this means is f times g, how do I write this? F of x times g of x. So we're just going to multiply these functions together. And because the input is x, we just take the functions as written. So x squared minus 6x plus 8. Then we're going to multiply that by x minus 2. I do some distributing here, so I get x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Moving down, negative 6x times x is negative 6x squared. Negative 6x times negative 2 is plus 12x. And then 8 times x is 8x. 8 times negative 2 is negative 16. And then we can combine like terms. I don't have any other cubed terms, but I have these two squared terms. So negative 8x squared. And then 12x plus 8x is 20x. And then minus 16. So that is f times g of x. All right, and then we have two last ones, and these ones are division. So f over g of 3. 3 is now the input, so what this means is f of 3 divided by g of 3, which f of 3 is x squared minus 6x plus 8 over x minus 2. And that's pretty good, but I think that we can factor the numerator. That's going to be x minus 2, x minus 4. What we'll see is that the x minus 2's cancel, so we just end up with x minus 4 here. And I actually did this a bit wrong because I treated this input as just x, so I'm just going to change that. So that's really this problem that I just did. Okay, so now if I want to do f of 3, f over g of 3, I can actually use what I just found here. I could put 3 into that. 3 minus 4 is equal to negative 1, and that works. But if I don't want to do that shortcut, this is f of 3 over g of 3. F of 3, well, I'm putting 3 into this f function up here. Doing that in my head, 3 squared is 9. 6 times 3 is negative 18. 9 minus 18 is negative 9. Plus 8 is negative 1. So I get, I don't know why I wrote 8. Negative 1 in the numerator. And then putting 3 into this function, g of 3, I get 3 minus 2 is 1. So this also comes out to negative 1. So notice that those are the same. Okay, so a lot of color on this page, but hopefully you're able to follow everything that was going on. All right, and then the next example, similar idea. We have slightly different notation here, and we also want to find the domain of these 4 operations: f plus g, f minus g, f times g, and f divided by g. Okay, so f plus g, what that means is just add the f function plus the g function. So square root x plus 2 plus square root 5 minus x. Okay, so to find the domain of all of these, I'm going to actually calculate them first. So that's f plus g, f minus g. That's just square root x plus 2 minus square root 5 minus x. F times g, this will be square root x plus 2 times square root 5 minus x. So when we're multiplying two things that have radicals, what we can do is we can multiply the radicands together. So x times 5 is 5x. X times negative x is negative x squared. 2 times 5 is plus 10 minus 2x. Okay, and just rearranging this or simplifying, I get 3x minus x squared plus 10. So there is f times g. And then lastly, f over g. That's just going to be the f function, square root of x plus 2 divided by the square root 5 minus x. All right, so let's go through and find the domain of these. And we'll see that there's a pattern. So the first thing I want to do is find the domain of each of the individual functions. So the domain of f, remember, to find the domain of a radical function, we take the radicand, we set it greater than or equal to 0. So x is greater than or equal to negative 2. That's the domain for f. So x has to be greater than or equal to negative 2. So we're going to say negative 2 to infinity. For g of x, I take 5 minus x, set that greater than or equal to 0. I'm going to move the x over, so I get 5 greater than or equal to x, which is the same thing as x less than or equal to 5. I can just reverse everything, do a mirror image, and rewrite it like that. Oftentimes, I like having the x on the left side. So combining these, if I have x greater than or equal to negative 2, but less than or equal to 5, on a number line, putting those together, well, let's not get there yet. I'm getting a little ahead of myself. But what we see is when I do f plus g, the domain, to find the domain of these combination functions, what we want to do is we want to find both domains separately and then see where there's overlap. So the domain of x plus 2, or the f function, so the domain of f of x, if I do that on a number line, this is saying from negative 2 to infinity. So it's all of this. And then the domain of g, well, that is up to and including 5. So it's all of this. So if I think about what the overlap is, it's this portion right here between negative 2 and 5. So what we'd say here is that the domain of f plus g is from negative 2 to 5. Okay? And that's how all of these are going to be. So the domain for f minus g is the same thing. It's negative 2 to 5. The the f times g function is going to be the same. If we don't see that, we can take what the function we get when we multiply that together. If we were to graph the radicand here, we're going to have a parabola that opens downward like this, and we want this to be positive. We want that radicand to always be greater than or equal to 0. So we can see it's between -2 and 5 here. So the domain of f times g is from -2 to 5. Okay. Now, things are a little bit different when we're talking about the division. This is the one operation that we need to be extra careful about, because we need to figure out we need to take care of what value in the denominator may make this equal to may make this a negative, or 0, I should say, 0 or a negative. Now, we don't want 0 in the denominator because that will give us something that is undefined. So what we have seen is the domain of these previous ones, we had -2 to 5, and we're including those endpoints. The issue here is that if I input 5 into that denominator, I'm going to get 0 in the denominator. So we want to go up to and including 5. So we're going to write it like this. So that would be the domain for that division. So that's what you got to be careful of when we're dividing functions. The domain may be slightly different in that case.